God. Welcome back to Thursdays with me. It's May 19th, and we are going to talk about data sufficiency problems where you have to do something with the stuff in the prompt. Okay, and again, let's just show, for completeness' sake, let's show the copyright notice again. So there's that. And here is a problem. Okay, there should be a question mark after that. So let me go ahead and add the question mark where it should be. And don't forget where, we do assume that you understand what the data sufficiency format is in general. So we're going to assume that you are familiar with that. That's where you get the multiple choice answers. Standard data sufficiency answer choices. So A, number 1 only is sufficient. B, 2 only sufficient. C, neither is sufficient. 1, but together they are sufficient. D, each of number 1, number 2. Okay, go for it. All right, if you don't have, oh yeah, no, don't use the chat box. I'm not sure what, I'm not sure which part of that was unclear, guys. Please don't post your answer in the chat box. Also, this is a data sufficiency problem. The answers to data sufficiency problems are not numbers anyway. They're the answer to data sufficiency problems are A, B, C, D, or E. But anyway, let's pick something here. If you don't have an answer to this, you should pick an answer to this. We've got. I don't normally put answer distributions on the board, but we have a very interesting answer distribution here, so I'm going to. Here's what we have. We had lots of people picking 3 different answers here. So we have people picking B, we have people picking C, we have people picking E. So, interesting. Very, 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 very interesting. Okay, so what I want to do here is I want to introduce you guys to 2 hypothetical people that I also talked about in a couple of my classes. But let's use an easier example to introduce these 2 hypothetical people. Here's an easier example. What is 2x plus 2y is the question. And statement 1 is x plus y is some number. And statement 2 is x minus y. Okay. All right, what's the answer to that? That one you put in the chat box. Okay, that one is A, right? Because you guys see how this is A, right? Smiley face, if that makes sense. You see how this is going to be A. I mean, you should be able to see right away how this is A, because if you have this, you can just double it, and that's going to give you 2x plus 2y. You might need to think for a second to actually prove to yourself that statement 2 is not sufficient. I mean, if you, for example, if x and y are 3 and 0, then this is going to be a small value. And if it's 103 and 100, then this is going to be a big value. But, you know, for the most part, it is pretty easy to see. Now, here's the deal. I mean, let me introduce you to 2 hypothetical students doing this problem, whose names are Nancy and Schmancy. Okay. Nancy and Schmancy. That's their names. See, this is the goal. This is the goal of the problem. That right there. The goal of the problem is to find what 2x plus 2y is. Okay. Nancy actually understands the goal of the problem. Okay, my internet is stupid. I did take a screenshot of everything I tried to write. So, here's everything you should have seen on the board. Okay. So Nancy in this problem understands what the goal is. She understands the goal of the problem is to find 2x plus 2y and not x or y. And so she gets the problem right because she understands that's the point of the problem. So because she understands that you don't have to get x or y, so she picks A. On the other hand, Schmancy doesn't. Schmancy just has this attitude, I want to try to find everything. Like, Schmancy's goal is, I just want to try to find every piece of information in the entire problem. So what Schmancy will try to do is Schmancy tries to find x. Schmancy tries to find y. And if you think you actually want to try to find x and y, then you're going to pick choice C, and you're going to get the problem wrong. And I mean, what you're looking at here, like in data sufficiency, like this is the thing. I mean, when you look at data sufficiency, like this right here is actually the entire purpose of data sufficiency, is for Nancy to get the problem right and for Schmancy to get it wrong. Because like when you, for multiple choice, this can't happen in a multiple choice problem. I mean, if I gave you a multiple choice problem, and I gave you this equation and I gave you that equation, then you could just use them both and you could find x and you could find y. You can just do it. But, I mean, only data sufficiency has this format where you might use them both, but you might not. And so that's why they actually invented this entire problem type specifically so that Nancy gets it right and Schmancy gets it wrong. So if you look at this, Look at this now. Consider this question. I mean, remember to be Nancy, don't be Schmancy. Because, okay, also consider, like, okay, if you are Schmancy in this problem, think about when Schmancy gets this problem wrong. Notice that no mistake actually happens here. I mean, that's the most interesting part of this. Like, the point at which Schmancy gets this wrong is before she even starts working on it. Yep. Like, literally before she even starts. It's like pre-order wrong before it's even in stores. Like, if you think I want to find X and Y in this problem, you've actually gotten the problem wrong before you even start working on it. Yep. But it's already wrong. So, like, consider this. The problem here is, what is the ratio of Kn to Mn? If you think that you want the values of Kn and Mn, you have already gotten this problem wrong. Yeah. Like, before you even start doing the work. If you think you want numbers for Kn and Mn, whoops, you're already dead. But you haven't even started the problem yet, and you're dead. Already wrong. You have zero chance of getting it right because you are dead already. Your name is Schmancy, and you are dead. And this is the thing with data efficiency. I mean, it's not like multiple choice where you have to actually make a mistake along the way somewhere to get things wrong. I mean, nope. If you get these things wrong, you get it wrong before you even start them. You have to have the goal of this. You have to understand that you are going to find the ratio without finding those actual things. Aha. This is the Nancy approach. You should expect to find the ratio you should expect not to find the numbers. That's how this is going to work. And again, it's just being sophisticated, right? It's kind of like the data efficiency version of being grown up, almost. Yeah, it's like a data efficiency version of not being a little kid anymore. And, it's like the data efficiency version of understanding when something is a scam on the internet or something. It's sort of like that. So, okay. All right, so statement one, I mean, you guys realize, I mean, nobody thought statement one was sufficient, so we were good there. I mean, if you know this is dirty around here, that doesn't tell you anything about how they subdivided it. So, because this could be anything, right? So, overall perimeter doesn't tell you anything about the ratio of length to width. So, no information about width to length. But, so that's not sufficient. But on statement two, The three small rectangles have the same dimensions as each other. Well, well. Okay. What does that mean? Well, if we think about that here, if this is like an X, like the little dimension, if the little dimension there is an X, that means that's also an X, and that's also an X. Oh, well, wait just a second. That means that this dimension is 2x. So this is also 2x. Aha. So that's 2x. And so that must also be 2x. And that's x. And that's x. And that's 2x. And so the whole thing has, mn is 3x. And kn is 2x. And so this ratio has to be 2x to 3x. It has to be. So that's going to be a ratio of 2 to 3. So this is sufficient. And if you were to throw numbers in there, like if you actually plug numbers in for one of those sides, then it would always turn out to be the same way. But the deal is you don't find out what the dimensions are. And if you're like the data sufficiency equivalent of someone who has kind of grown up a little bit and understands like how data sufficiency adults work, so to speak, then you get it, right? You understand that you understand that it's not going to work like that. You're not going to find out what the actual dimensions are. You're just going to get the ratio. That's all you're going to get is the ratio. Nothing but. Yeah, but Nancy Schmancy kind of thing. The point is that's what this is all about. That's kind of on a very fundamental level. This is why they made data sufficiency. This is why it is a thing. So, but just be aware of this, because if you are on the wrong track, you're not going to know, right? Because if you are Schmancy and you are doing this problem, if you want your X and your Y, you're going to get them, and you're going to pick C, and you're not going to think that anything is wrong with that. Like, same thing here, if you think you want numerical dimensions, then you're going to get the answer C to this problem, and you're not going to think anything is wrong with that. But if you think you need numbers as dimensions here, that means you got the problem wrong before you started it. So you have to be on the right track right at the beginning. You have to understand what the goal is and isn't before you start working. Any questions? All right, let's do that. Let's see our problem. Cool. Let's see. How about this one? Remember where your multiple choice answers are. No, we can't use the OG. These are all from the free GMAT prep software, as mentioned at the beginning. The official free GMAT prep software from GMAC. Yeah. All right. Give it a shot. Okay, we should probably pick something pretty soon. And remember, the fine art of time management for this exam is not really a fine art at all. It's really, time management of this test is really just, hey guys, are you actually getting somewhere? And if you're not, then stop doing what you're doing. Kind of all it is at the end of the day. It's, I mean, because, when I said just now, hey, are you getting somewhere with this? It's time to pick something. About 8 of you picked an answer right when I said that, which means, remember, you're not going to have my voice annoying you guys during the test. So if you need me to do that, that's not great. FYI. Okay. So, all right. Anyway, let's discuss. We're kind of, the answers are sort of all over the place in this one anyway, but let's talk about this. I mean, all right. So, when you look at a problem like this, when you look at the statements to this problem, I mean, you have, I mean, okay, when you think about writing a problem like this one, I mean, here's kind of a stupid question, but maybe it's not such a stupid question. When do you think somebody would write a statement like that one? I mean, I know it sounds kind of vague, but let's see if anybody knows where I'm going with this. Aha! Exactly. If one of the statements is like, hey guys, D is positive, then in the other statement you should think about if C is not positive. That is the point. Aha! That is the deal. I mean, same thing, right? And same thing with the other one. If it's not, same thing with statement 1, is you should immediately, if they have to specify that n is non-zero, you should immediately think in the other statement about whether n is 0. Yeah, because like each of these things looks like it's taking away possibilities. At least it should look like that to you. And these statements look like they are taking away possibilities. These kinds of statements that look like the point is to narrow down or to remove possibilities. It can be smiley face if you see what I'm talking about there. I mean, it's different from, like, if you have something that is, like, as opposed to something like this, like the 3 small rectangles have the same dimensions. This is not removing possibilities. You guys, the smiley face, if you see the difference that I'm talking about there. Like, this is so much more specific that, like, they're specifically trying to do something there. Okay, like same dimensions is not taking away possibilities. That's like actually specifically making something happen. That's the difference that I'm talking about. I mean, this is specific enough that it's doing something, as opposed to these are not really specific enough that they're doing something, but this is more like taking away a set of possibilities. Like, okay, well, non-zero is not really specific enough that it's doing something, but at least I'm telling you that it's not zero. So, like, this is, you know what I mean? So, like, this statement is like, it's actually doing this. Versus these statements are more like, it's not doing that. I mean, I guess that's the difference, right? You should try to segment the statements into, some of the statements are telling you it's doing stuff, like that one. And other statements are telling you it's not doing stuff, like these ones. Basically, two kinds of statements in the world. It's doing stuff or it's not doing stuff. The statements about it's not doing stuff, like these, you should think about the flip side of that when you consider the other statements. So if you get, it's probably a crappy way of explaining it, but it's the best I can do right now. So if you get, when you see a statement that says this doesn't happen, or this isn't true, then when you consider the other statement, always think about the flip side. That's the point. So if statement 1 says n is a non-zero integer, then in statement 2 you need to think about 0. And in statement 2, think about maybe z being 0 or negative. In statement 1. That's the point. So, should non-zero tell you? Well, yeah, but the deal is in the other statement. I mean, because if they're telling you that, then the point is that there's a reason why they're telling you that. So, I mean, because the deal is, if as the question writer, I mean, if I was only thinking about positive and negative anyway, then there would be no reason for me to even tell you that in the first place, is the point. So, you know, like if there were only positives and negatives anyway, then there would be there just wouldn't be a reason to even go there at all. So, okay. All right, so let's think about it. Let's think about the statement. Yeah, that's true. In the last problem, you don't even have to get that heavy of a statement one in the last problem, but that's also true. Okay. In this problem, let's talk about this. So z to the n equals 1. So let's consider all the different ways that this could be true. I mean, how many different ways could you have z to the n equal to 1? I mean, how many ways? How could this happen? So you could have So again, with non-zero integers, that means you should also think about 0, right? So then, okay. I mean, you could have things like 2 to the 0 equal to 1. So you could have possibility number 1. Things like 2 to the 0 equals 1. So, in other words, etc. So in other words, Z is a positive, well, so Z is non-zero. Well, let's not be that abstract about it. Let's do it for the statements. Okay, statement 1. All right, statement 1. All right, so we know that n has to be non-zero. And we know that z to the n is 1. And then we know that we should be, because of statement 2, we know that we should be aware of z is 0 or z is negative. Okay. So, okay. How are we going to do that? Aha! Yeah, you have -1, right? You can do that. So, and n is non-zero, and z to the n is 1. So let's do that. Yeah, exactly. So, I mean, you could have 1 to the, like, 5th or something equals 1. So that is like n is 1. No, the n is 5. Z is 1. And n is 5. So, exactly. But then, you can also have -1 to the some power, like 6 or something like that. Look at that. And I mean, maybe if you weren't tipped off, if your hand was not tipped by statement 2, then you probably wouldn't be as aware of something like that. That's the point, right? Yeah, look at that. Oh, my internet. Okay. So what they're doing with statement 2 is they're ruling out that. That's what they're doing, right? I mean, that's basically the point. The point of statement 2 is very specifically to rule out that. And that's what you should, that's the point. So, okay. Because statement 1 is not sufficient because you have 2 values of z. And that's the point, is that you don't need to think of the negative z through some amazing, brilliant mental light bulb moment. You can be guided towards it very deliberately by looking at the other statement. So statement 1 is not sufficient. Okay. Now let's look at statement 2. All right. So statement 2 tells you that z is positive. I mean, statement 2, z can be any positive number. So this is going to be, I mean, if you can have the 0 power for n, I mean, that's not going to tell you what z is. So definitely not, right? I mean, you know. So like, you could have, say, 4 to the 0 is 1. So z is 4, and is 0. And then you can also have like 5 to the 0 is 1. Oh, look, that's not sufficient. And I mean, again, notice that you should be, and again, you need to think about that because statement 1 tells you to think about it. Oh, look at this. I mean, statement 1, think about exactly why you should be thinking about that. You should be thinking about that because statement 1, think about why statement 1 is there. Like the moment you see that, you should be like, oh, well, the moment you see this, you should know to use n is 0 in statement 2. Because otherwise there would be no reason they would ever make statement 1 look like that. Obviously not. I mean, like, nobody would ever randomly make statement 1 say that. That would not ever happen, is the point. So this is not sufficient because you have 2 different values of z. Okay. Now, if you have the 2 statements together, if you combine them, then you're going to find out that the only way that you can do it is to have something like that. I mean, the only way that you can have a positive z to a power equal 1 is if it's 1 itself. You'll find that out. Like if z is actually a positive value. And n is a non-zero integer. Because if n was some other integer, then if you had a positive value, if n was any other value, it would be either bigger or smaller. So if you combine the statements, if you mess around with that, then you'll discover that if you combine the statements, to make z to the n is 1 happen. So see. What about a negative integer for n? I mean, well, so if you think about it, I mean, if you try to come up with the numbers, you're going to fail to come up with the numbers. But if you have a non-zero integer, I mean, okay, if you have a positive integer for some, okay, we're talking about positive integer that's not 1. Like if you try to come up with anything other than 1 for z. So let's say that z was 2. Then you can see why this is not going to work, right? Unless n is 0. It's not going to happen. Because if n was any power smaller than 0, then it would be a fraction. And if n was any power bigger than 0, then it would be bigger than 1. And then any integer that is larger than 2 is just going to act like 2. So it's not going to happen. So the only z that's going to work is 1. Yeah, that's how it's going to work. But I mean, just play around with it, right? Just throw numbers in there and watch what they do. So it's going to have to be 1. Z is going to have to be 1. I mean, you're not going to be able to find n. I mean, n is still going to be anything you want. I mean, you're going to find out that it's going to be 1 to the. I mean, again, it's Nancy and Schmancy again. I mean, I think you might be trying to be Schmancy. I mean, you still don't find n. And you still don't care. If you're trying to find n, you're going to think the answer is B, and you're going to get the problem wrong because, again, you're being Schmancy again. It doesn't matter. But the goal of the problem is not n. The goal of the problem is z. And the only thing you find, it doesn't matter. You don't care about n. It makes no difference at all. I mean, n can be negative, and sure it can. It doesn't make any difference. I mean, n can also be, I mean, in fact, n can be 0 too, and it still doesn't matter. But it makes no difference. Because we only care about z. But, I mean, they do rule out 0, but it doesn't really matter. So, because again, Nancy only cares about z, not n. I mean, it is brilliant the way that they make problems that focus only on the goal of the problem. I mean, it's pretty awesome how they do that. But just remember to focus on the goal of the problem. Okay, sweet. Let's do a problem. How about this one? Okay, let's go ahead and pick a response to this if you don't have one already. This one, this one shouldn't take as long as it has taken some of you guys. I mean, remember that the amount of time these things should take should be roughly proportional to how much crap is on the page. I mean, that's like the amount of stuff that's there is a pretty good approximation for how long the problem should take. I mean, it's not a perfect approximation, but it's pretty good. I mean, as far as an estimator for how long it should take. I mean, there's not a lot of stuff on the screen. Like, you don't have to wander through a big paragraph here, and you don't need to, like, decode a bunch of words into math. And so, yeah, but simply put, this problem shouldn't take forever. So, yeah, okay. Doesn't mean it's easy. It just means it doesn't take that long one way or the other. So, okay. If you don't see what the deal is with this problem, I remember with data sufficiency, there's exactly two ways to approach life here, which are these. You can either use basically theory, or you can just start throwing numbers in there and seeing what they do. Okay. Yeah. I mean, what kinds of numbers, or like what kinds of concepts, at least, what kinds of math concepts does this have to do with? Like when you see, well, I mean, of course, absolute values. I mean, those are what's in front of your face. But like, yeah, it's going to have to do with positives and negatives for sure, right? Is where I'm going with this. Because absolute values change when things are, I mean, you should be thinking about signs is the point. I mean, whether or not whether or not this looks like a problem about signs right away, you should definitely be thinking about signs. Because if you think about absolute values in general, that's when absolute values change behavior, is with signs. I mean, an absolute value does one thing when numbers are negative, and another thing when they're not. Like it flips the number when it's negative, and it kind of leaves it the heck alone the rest of the time. So, you know, like it's gonna mess with x and y when they're negative, and it's gonna leave them alone the rest of the time. So you should be thinking about the signs of x and y. So yeah, I mean, in terms of testing cases, I mean that's a particularly easy thing to do. In terms of testing cases, you can just throw the numbers in there with different signs. And I mean, also, as far as this is concerned, that's also a thing about signs, right? When you product is negative means what? What does negative product mean? It means they have opposite signs. It means one is positive and the other is negative. So that's what that is. And so that's another reason to think about that. So this is just, I mean, you should definitely be thinking about signs the whole way through this thing. So again, for statement one, I mean, so statement one is not inherently a sign thing, but you should still think about numbers of different signs as you plow your way through statement one. So, in other words, you gotta make y less than x, of course, to satisfy the statement, but you need to make that happen. But then the point is that try different signs while you're doing it. So, and then of course to test the cases, just use columns, right? So you're going to make a y, you're going to make an x, and then you should just, okay, so you have an x, absolute value x. So x minus y, and then, okay, now if you're me, I mean, what you should do is basically don't make yourself do anything in your head. So that's always a mistake. So you have the x minus y, then take the absolute value. And then these things, you got to find them before you subtract them. So find them, and then subtract them. And then those things, right? And then in terms of the actual question, this thing, this is a yes-no type question. This has been in a couple of these sessions before, but when these questions are yes or no, remember you want to find these two possibilities. So all right, let me set this up and then I'll talk about it. Okay. So all right, so the yes and the no possibility are these respectively. And then you can make that happen and make that happen. If you can make both of these happen, then that's not sufficient. So, and you want to try to do that for each of the statements. And we've had entire study halls. If you have no idea what I'm doing right now, then you should watch the study hall sessions on yes, no, style, data sufficiency problems. So this is the no case. This is the yes case. This is the no case. The point is you organize the problem like this, and then you just check off the things that you make happen. You put check marks in these areas if you make them happen. That way you have your goal in front of your face. Check mark if you make it happen. And then if you have 2 check marks in a column, that's not sufficient. The goal is in front of your face, basically. So the deal is that this is one of your columns. Let's compress this a little bit. Okay, so like this is one column right here, and this is the other column. And if this is greater than that, it checks off that box. So if this is less than or equal to that, checks off that box. But the point is, you're not. And I mean, I've commented on this at various points, but one thing which does me no favors in other areas of life, but which I think is actually a strength in the GMAT, is that I personally have a first percentile memory. That's actually the lowest percentile of the human population. That's actually correct. I have a memory in the lowest percentile of the human population. Like on my worst days, I have to check my own IT for my great day. That's actually not a lie. I had some brain damage when I was 7 years old, and it affected some of the parts of my brain that use memory. I mean, this test is actually specifically designed to rely on memory as little as possible. I mean, that's actually what the GMAT is. Like the GMAT is specifically a test that relies on memory basically almost not at all. That's what the GMAT is. It's a test that is like it's a non-memorization test. In fact, it goes beyond that. Like the GMAT is a test that is memorization proof. Like not only is it a test that doesn't rely on memory, it's a test that you cannot do well on by memorizing stuff. So that's actually the entire point of the test. That's why it exists. Like if you could memorize your way to success on this test would not exist at all. So, I mean, you know, I got mediocre grades in most of school because I can't memorize stuff. But, you know, anyway. The point is that in terms of this, like, it helps me because I don't even try to do that. Because, like, I see a lot of students who are stuck at, like, in the 40s in the quant section and who don't get higher than that because they try to do stuff in their heads. Like, they'll try to do all these steps mentally. And they'll also try to do this mentally at the same time, and that's too much to be doing mentally. I mean, you know, you can't manipulate all this crap in your head and also do this and also try to remember whether the statements are sufficient or not sufficient all at the same time in your head, guys. I mean, you should just write down all the freaking steps on the paper. Like, okay, basically, here is the most important rule that you can know about this stuff. It's a very simple rule, and it is completely bullshit-proof rule. Here's the rule. Here's Ron's rule of success. Number 1 here. If you ever have to remember anything while doing anything else, you're not writing enough stuff down. Period. There. You should never have to keep any information in your head while doing anything else, ever, at all, ever. Period. End of story. No exceptions. I hate my internet. Okay. So you guys, it looks like you saw my rule of success, right? If you have to remember anything while writing anything else down, then that's fail. I mean, you're not writing anything down. I mean, you should not have to write. I mean, you should not have to keep anything in your head is the point. So if you're interrupted while you're doing the thought process, that should be fine because you should be able to follow your own writing anyway, and just be able to follow what's going on. So okay, I mean, let's do that with the let's just throw some numbers in there. So statement 1, okay, so y is less than x. I mean, you start with things like 2 and 3. Okay, so x minus y is 3 minus 2. And the absolute value of 1 is still 1. So absolute value of x is 3, and the absolute value of 2 is 2. And that is 1. So that is not greater than that. Okay. See? I mean, that's how easy it is, right? Just follow it. I mean, if anybody's worried about time here, there's 2 responses to that. First, being worried about that is stupid because the time that it takes to set this up is like 10 seconds, guys. But on top of that, the time that you take to set this up, you will more than get back. I mean, because notice how smooth it is to go through this. I mean, it's like negative time investment because you will easily get back and more. You will get back the time that you spent making So, okay, now consider signs. I mean, signs are the thing you should be thinking about. So let's make one of them negative. So let's say that y is -1 or something, and then x is 1. So x minus y is 2, and the absolute value is 2. But then x, absolute value is 1, and absolute value of y is also 1, so that's 0. And then, so that is greater. So not sufficient. All right, how about that? Boom. Okay, now, statement 2 is the same thing. So we just have to make them opposite signs. And we can reuse these numbers because these still count. That was a terrible way of circling that. I mean, we can still use these two because those do have opposite signs, right? So we can check mark that box again. If we try other values, I mean, if we try like y positive and x negative, okay, x minus y is -7. So that's +7. And then absolute value x is 3. Absolute value y is 4. And so that is negative. Still greater. Still checks this box. Okay, and if you keep doing more examples, you'll always check the top box. And if you keep doing this, you'll find that you never actually check the bottom box. So this actually winds up being sufficient. So, and you actually never, because statement 2 is sufficient, you never wind up combining them. So this is B, boy. You don't combine them because it's sufficient. I mean, you can, if you think about this in the abstract, you can kind of see it. I mean, when you subtract out this is going to be subtracting something that's positive or 0, whereas this might actually make that bigger. I mean, but if you don't see that, you can just throw numbers into this organized framework. But the most important lesson here is just this procedural organization stuff. And I mean, the one thing about the two things about this test that you guys should really absorb, and you should really absorb it like right now, yesterday, are that number one, there's no light bulb moments. I mean, the one thing that is super consistent about this test is that the problems never, ever, ever depend on some light bulb insight type thing. They really never do. I mean, like, you know, I mean, actually, that's the one thing about this problem that you should notice. Like, even the things that seem like light bulb insights the clues are there in the problem. Like the fact that you have to think about -z, there are signs almost posted right there in the problem that tell you to think about -z. Like, you never have to just brilliantly, randomly think about stuff. Never, ever, ever, ever. It's really kind of cool. So if you do your due diligence and you follow the posted clues that are in the problem and you are just very organized about your thoughts and stuff, and you just relentlessly write stuff down, I mean, you'd be all right. But like, really, guys, do not do stuff in your heads. Do not do it. And I mean, I've noticed that there are some students who seem to take this weird, like, they seem to have their egos invested in doing lots of stuff mentally. Do not do it. I mean, there have been studies that show that mental math There have been studies that show that people make about 40 to 50 times as many mistakes in mental math as they do on paper. Like literally 40 to 50 times as many mistakes. It's a lot of mistakes, guys. 40 to 50 times. I mean, I don't know about you, but I would really like to make 98% fewer mistakes. All you have to do to make 98% fewer mistakes is write the stuff down that you do. That's all you have to do. And it's faster. Like, doing this is much faster than trying to do it in your head. So, do it. Don't try to do stuff in your head. Don't do it. Okay, we got to run here. Yeah. So, and when you review the problem, I mean, really try to go overboard. I almost dare you. Like, try to over-organize these problems because I swear you will not be able to do it. I mean, like, what you think of as being, like, overly organized to the point of that being, like, your annoying librarian from 2nd grade, it'll still only take you, like, 10 extra seconds, and then you will gain back that 10 extra seconds almost immediately the first couple of cases you plug in. So, you're welcome. I appreciate the kind words. We do another one of these sessions actually in just 1 week from now because of the way the schedule worked out. So, all right, that's it. You got to run time, and I'm on kind of a tight schedule, so got to cut it. I'm going to kill the recording here. Thank you. Good afternoon. Good evening. Good night. Good luck.